Alrighty, guys, here we go. Starting with question number 4 this time around. And please give the questions a try before you watch this, as always. Okay, number 4. How many normal license plates are possible in the state of Hawaii? The normal license plate has 3 letters and 3 numbers. Okay. So, you got 3 letters followed by 3 numbers. How many options for the first letter? Well, there are 26 letters in the alphabet. So 26. Second letter, I can repeat, right? So because I can repeat, it's an FCP question. 26 options again, and then 26 again. And then what about the numbers? Numbers, they're 10 digits, 0 through 9. 10 digits, 10 digits. Right now, at the moment, we're assuming that all letters, all numbers are fair game. There are no restrictions on which letters or numbers we can use. Now, if you want to condense the notation slightly, you can say that's 26 to the third times 10 to the third. Either way, they mean the same thing, right? The third power just means to multiply it by itself 3 times, and that's exactly what you have here. Okay, I'm just going to punch this into my calculator and assume that you guys are able to do that same thing. And I get 1,757,6,000. Oops. Sorry. 6,0,0,0,0. So that's 17 million. Wow, 576,000. Quite a big number, yeah? With only 6 spots, 3 letters and 3 numbers. Okay, number 5. How many normal license plates are possible if there are 50 letter combinations that are not allowed? Okay, interesting question. There's 2 approaches to this question. One is to figure out, take this whole number that we just calculated a moment ago, and then subtract how many total outcomes are not allowed. So that's one approach. Another approach is to take out the letter combinations on the front end, and then finish up that way. But I think personally, since we already did that work of calculating the total beforehand, I think the most natural, easier method is to figure out how many 50 letter combinations license plates there are total. So like what I mean by that is how many license plates are not allowed. So I'm going to write that here, not allowed. Okay, so as far as the letters are concerned, there are just 50 combinations of those, right? There's 50 of those. Things like probably, I don't know, ASS or something is not allowed. Or maybe 000 is not allowed. I'm sorry, I mean 000 because it looks like zeros, right? Okay, so I got 50 of those, and whatever they are, they're not allowed. For each of those letter combinations, though, they could have any of a number combinations, right? And how many number combinations are? 10 possible digits for the first one, 10 for the second, and 10 possible digits for the third. So that means altogether, I've got 50 times 10 times 10 times 10 letter and number combinations that are not allowed. So in other words, 50 times 10 times 10 times 10 license plates that are not allowed. What is that? That's 5 with 1, 2, 3, 4, 0. So 50,000 license plates that are not allowed, right? Those are the ones that have those 50 letter combinations that are not allowed, along with all the different possible number combinations that could go with them. Okay, so now I come back to how many total license plates are okay. Okay, well, I already figured out in my previous question how many were total, and I just got to subtract this number, and then I'm there. So I go 1,757,6,000 minus 50,000. That's going to equal, excuse me, my answer. All right, so that's 1,752,600. I'm sorry, 6,000. So that means 17,526,000. All right, number 6. In Honolulu, license plates cannot use the letters I, O, Q, M, H, or K. The first 3 aren't allowed because they resemble numbers, and the latter 3 aren't allowed because they are reserved for Maui, Hawaii, and Kauai. Assuming 3 letters and 3 numbers, how many license plates are allowed on Oahu? Okay, so, and this is actually a true story, guys. Real story. They actually have restrictions like this. Okay, so normally when we answer this question, talking about license plate, right? I've got 26 options for the letter. And then I've got 10 for the, these are the numbers. Numbers are not affected here, right? So 10 times 10 times 10, that's the numbers. The letters, normally I have 26, but here I have 1, 2, 3, 4, 5, 6 letter combinations that are not allowed. Or I'm sorry, not letter combination, but letters. Which means I shouldn't have 26 then. This should be 20 minus 6, which is 20. 1, 2, 3, 4, 5, 6, yeah. So there's 20 different letters that are allowed. Second position, another 20, and then another 20. So altogether, how many things are allowed? 20 to the third times 10 to the third, which is equal to 8 with 1, 2, 3, 4, 5, 6 zeros. That seems like a lot less than 1, 7, 5, 7. Oh, yeah. Huh. I guess that's right, though. Yeah. So actually, that made a really significant difference. Where we went from 17 million something to only 8 million. Oh, I guess it's not so crazy. Yeah. 1, 2, 3. Am I counting those zeros correctly? 1, 2, 3, 4. Yeah. Okay. All right, 8 million. All right, number 7. How many normal license plates are possible if no repetitions are allowed? Okay. So I admit, guys, there's some ambiguity to this question. When we say normal license plates, I mean, coming back to question number 4. How many normal license plates are possible if no repetitions are allowed? So, if no repetitions are allowed, what does that mean? That means it becomes a permutation question, right? No repetitions are allowed. So there's 2 ways you can do this. You can just kind of think of it the same way with the spaces. The first position for letters, I got 26 options. And then 25 because I can't repeat, right? And then 24. And then for the numbers, it's 10, and then 9, and then 8. But what do we have here, guys? What did we just do? Check this out. This number here, 26 times 25 times 24, that's the number of ways to take 3 letters and permute them, right? So do you guys see? This is actually NPR 26, 3. And if you remember back to when we first learned permutations, we figured out this was the formula, right? That's how we approached permutations. So that times the number of number combinations, which is also permutation because I can rearrange the numbers to get something different each time. And what are the numbers there? Well, there's 10 possible digits, and I want 3 of them to make my license plate. So you can do it either way, guys. You can multiply this out together. That's totally fine. Or you may have thought of as 2 permutations multiplied together. Also totally fine. If you want, try out both ways. And just to confirm that you get the same thing, whichever method that you prefer. Okay, I'm just entering this into my calculator. See what I get. And the answer is 1, 1, 2, 3, 2. Oops. 0, 0, 0. So 11,232,000. Okay, let's do 2 more, guys, and then we will cut this video off, take a little break. Rate, how many ways can a club of 20 people elect the president, vice president, and treasurer? This should be an NPR question because I've got positions. And I got 3 positions, bigger number first, smaller number second, yeah? All right, I'm going to just enter this into my calculator. 20, 3, the permutation. And the answer is 6,840. All right, one more for this video. Number 9, you flip a coin 2 times. How many outcomes are possible? Assume that flipping a head and then a tail is different from flipping a tail and then a head. Okay. This is an FCP question. And I can illustrate this with the tree diagram if I want to as well. So what are the outcomes? I could have a heads or I could have a tail, right? And then tree diagram, if I toss a head first, next coin I could toss a head or a tail. If I toss a tail first, next coin I could toss a head or a tail. So you see how many outcomes possible? 1, 2, 3, 4. Where did that 4 come from? Okay, first flip, I had 2 outcomes possible. Second flip, another 2 outcomes possible. 2 times 2 is equal to 4. See that? So there we go. All right, see you in the next video.